Welcome. Today we are discussing Module 9.1, Advanced RAG, Query Transformation and Re-ranking Theory. Here is a quick look at where we are in our curriculum. Welcome back, AI engineers. Today, we are moving beyond basic setups to address why your production RAG pipelines are failing. When a user asks a complex or poorly phrased question, a simple vector similarity search on embeddings often misses the most critical documents. To solve this, we must transition from simple retrieve and read to an advanced RAG framework that actively transforms user queries and intelligently re-ranks candidate documents. Today, I'm going to show you the architectural blueprints of how high-scale enterprise systems achieve state-of-the-art accuracy. Let's zoom into our first pillar, query transformation. The way humans ask questions is structurally different from how knowledge bases store answers. If a user asks a highly condensed question, traditional dense retrievers struggle. By utilizing HIDE, hypothetical document embeddings, we instruct a lightweight LLM to generate a hypothetical answer. Even if this answer contains hallucinated facts, its semantic structure matches the documents in our vector index far better than the raw query ever could, leading to a massive boost in recall. Now, let's look at a concrete implementation. To execute multi-query transformation reliably in production, you must enforce structured outputs. In this Python script, we define a pydantic schema called query expansion containing a list of strings. We then instruct our model to output exactly 3 distinct variations of the user query. Don't forget to check the link in the description to download this entire script and architecture diagram so you can run it locally in your own environment. Well, folks, it seems we've hit a classic live debugging moment, and honestly, it's a perfect teachable instance right out of the gate. As you can see from our terminal output, we've encountered a module not found error, no module named OpenAI. This traceback tells us exactly what went wrong. Our current Python environment doesn't have the OpenAI library installed, which our script relies on. The fix is straightforward. A quick pip install OpenAI in our terminal will resolve this dependency. This is a common hurdle when setting up new projects or working across different environments, and it's a great reminder to always ensure your dependencies are met. Let's get that installed, clear this hurdle, and then we can dive into the intended output, analyzing how user queries are transformed into precise technical searches. Now, why do we need re-ranking? Traditional vector databases use Bi-Encoders, like OpenAI's Text Embedding 3. These embed your query and documents separately, allowing fast vector operations but completely missing the subtle, deep semantic intersections between them. Cross-Encoders, on the other hand, do not create individual embeddings. They process the query and document together through a deep neural net, allowing full self-attention across every word. It is computationally expensive but incredibly accurate. This is the gold standard for production AI systems, two-stage retrieval. We cannot run a cross-encoder over millions of documents because it would be too slow and expensive. Instead, we use our fast vector database to do the heavy lifting, pulling 50 candidate documents in milliseconds. Then, we pass only those 50 candidates to our cross-encoder. This allows us to get high-precision ranking without sacrificing system latency. Let's explore the conceptual code for this integration. We define a robust two-stage pipeline where we fetch 50 initial candidates using standard cosine similarity. We then send these candidate texts, along with the original user query, to a specialized cross-encoder model. The results are sorted dynamically based on the model's similarity score, ensuring the ultimate best hits bubble up to the top. Again, make sure to check the description link to download this pipeline script and visual workflow. Whoops! Looks like we've hit a live debugging moment right here. The traceback clearly shows a module not found error for sentence_transformers. This means our Python environment doesn't have the sentence transformers library installed. This is a common pitfall, especially when working with new libraries, and it's a great reminder to always ensure your dependencies are met. A quick pip install sentence transformers should fix this right up. We'll get this installed, restart the script, and then we can properly analyze those crucial ranking changes. By combining structured query transformation and two-stage re-ranking, you now have the theoretical foundation to build state-of-the-art retrieval systems that outperform standard vector databases. In our next session, we are going to get our hands dirty and implement this in code. I will meet you in Module 9.2, Implementing Cross-Encoder Re-ranking, Practical, where we'll set up a live server and measure the performance gains ourselves. See you there.